Hi students, myself Tanmoy Datto, Assistant Professor, Department of Chemistry, JS College of Engineering. Welcome you all in the class of Oxidation Reduction, which is included in the Unit 3 of Basic Chemistry. In previous class we discussed about how to determine the oxidation number of a particular compound. But today we'll discuss about that with the help of oxidation number, how we can predict the oxidation reaction and reduction reaction of a redox reaction. And also we'll determine today, or we'll understand that how is it possible to balance a reaction by ion electron method. So first of all, if it is the any arbitrary example of the reaction, like if I write down here that it is the 2HNO3 plus 3H2S, then 2NO plus 3S plus 4H2O. This is any example of the common example of the reaction with balance. Now if I write down here the oxidation number of each and every case, like here it is the oxidation number of nitrogen, it is the +5, then the oxidation number of sulfur here, that it is the H2S, okay, it is the H2S, then it is the -2, then oxidation number is here +2, and sulfur 0 is the free atoms, so 0. So now then here look that +5 to +2, you have to keep in mind that decrease in oxidation number, this is called decrease in oxidation number, means it is the reduction. Okay, so just it is very important thing, oxidation number increasing, oxidation number increasing, that indicate oxidation, that indicate oxidation, and oxidation number decreasing, oxidation number decreasing, that indicate reduction. So this is a very important thing which you have to keep in mind when we are write down such type of way, that where oxidation occur, where reduction occur, then you have to understand properly that which is the oxidation reduction by this way. So +5 to +2, this is the example of the this is the example of decreasing the oxidation number, so this is the example of reduction. So it is the example of reduction. On the other hand, look here that here plus -2 sulfur, -2 to 0, okay, -2 to 0 means it is the increasing the oxidation number. Here it is the minus to 0, so increasing the oxidation number. So this is the example of oxidation. This is the example of oxidation. So look here that H2S, it is oxidized to sulfur, and HNO3, it is reduced to NO. Now which is the oxidant and which is the reductant here? This may be the question, that which is the oxidant and which is the reductant here. So if we consider the oxidant and the reductant, then here HNO3, it is the oxidant. Why it is the oxidant? Because it is self reduced, so it is the oxidant. And H2S, what is this? H2S is the reductant. It is the reductant. Why? Because it reduced the other compound and it self oxidized. So in this way we have to predict that where oxidation occur and where reduction occur. I can give you another example also from there. This is little bit the example is little bit another type, that if the reaction is like this, like if it is the if the reaction is in this way, we can write down that it is the K2 Cr2O7 plus 6 Ki, then plus 7 H2SO4, then what is produced from here? It is the 4 K2SO4 plus Cr2SO4 whole 3, Cr2SO4 whole 3 plus 3I2 plus here 7 H2. This is the reaction for any reaction. Now we have to understand, we have to identify which is the oxidant, which is the reductant, or where oxidation occur, where reduction occur. So first of all, here in K2CR2 we have to identify the oxidation number of each and every case. So here for chromium, here I already discussed that how to calculate the oxidation number for a particular compound. From this concept you can determine that here the oxidation number of chromium is +6, then the oxidation number of iodine, it is the -1, then the oxidation number of chromium here, it is the +3, and iodine 0. So if this is the example, then look here, chromium here, if you look the chromium, then chromium here +6 to +3. So +6 to +3 means it is the oxidation number is decreased. So if oxidation number is decreased, then it is the example of reduction. So it is the example of reduction. On the other hand, here -1 to +3, look here, it is the increasing the oxidation number, so it is called the oxidation. Now if the question arises here, which is the oxidant and which is the reductant, then K2Cr2O7, this is the example of oxidant. This is the example of oxidant because it oxidizes the Ki to I minus, Ki to I2, and it is self reduced. On the other hand, Ki, it is the example of reductant because it reduced the K2Cr2O7 and it self oxidized. So in this way we have to predict that where oxidation occur, where reduction occur, which is the oxidant, which is the reductant, etc., etc. Now come to the point that there are some kind of examples of the reaction, some specific types of examples of the reaction. That first of all, auto-oxidation reduction reaction. There are some redox reaction in which the same substance get partially oxidized and reduced. This type of reactions are termed as the auto-oxidation reduction reaction. Okay, so look here that in case of KClO3, this is the example of auto-oxidation reaction. So look here that if we take the example, so if we take the example of the like KClO3, okay, so KClO3, then KClO3 is converted to 2KCl plus 3O2. Now look here that why it is called auto-oxidation reduction reaction. Here Cl is the +5 and oxygen as well as -2. But in KCl it is the -1 and oxygen 0. So what is the result here? Cl +5 to -1. So +5 to -1 means it is the +5 to -1 means decreasing the oxidation number. So it is the reduction. And another way -2 to 0. It is the increasing the oxidation number and it is called the oxidation. oxidation. And this is the example of auto oxidation reduction reaction. Auto oxidation reduction reaction. So the another type of reaction, and this is called the disproportionation reaction. Okay, so what is the disproportionation reaction? Okay, so in disproportionation reaction, here in disproportionation reaction, a reaction in which an element of a reactant undergoes oxidation and reduction simultaneously, resulting in two substances in which one of the element exists in a higher oxidation state and other exists in a lower oxidation state. When I give you the example, it will be more clear to understand for this case. Okay, like if you take the example of the Cl2 plus 2NaOH, then what happened? NaOCl plus NaCl plus H2O. So now look here, Cl is 0, no problem, and here NaOCl, here Cl is the plus 1 and here Cl is the minus 1. So look here, if you take this example, then Cl2 to here, it is the 0 to plus 1. 0 to plus 1 means it is the example of oxidation. But if you take the example of the Cl2 to Cl minus, it is the decreasing the oxidation number. So this is called the reduction. It is called the reduction of the reaction. So look here, according to disproportionation reaction, that an element of any of the compound, any element undergoes oxidation and reduction simultaneously. So here it is the proper example of the disproportionation reaction, where if you look the example, that Cl2 only, it is responsible for the oxidation and for the reduction also. So that's why this is in the category of the disproportionation reaction. On the other hand, there is another type of examples also, and this is called the comproportionation reaction. Okay, now what is the comproportionation reaction? If we write down, so what is the comproportionation reaction? So if we take the example in this reaction in which two reactants containing a particular element but in two different oxidation states react with each other to produce a substance in which the said element exists in intermediate oxidation state. For example, if we take the example of KBrO3 plus, for example, 5 KBr plus 6 HCl, it produces 6 KCl plus 3 Br2 plus 3 H2O. So then here, look here, that beer is here. Beer, it will have the plus 5 oxidation state, but here beer is the minus 1 and here beer is the 0. So plus 5 to 0, it is one case. Another case, minus 1 to 0. I think you understand here properly that when we consider plus 5 to 0, then it will be the example of a reduction reaction. It will be the example of reduction reaction, and it is the example of the oxidation reaction. Okay, so this is the example of the comproportionation reaction. Now we will move to the how we can, is it possible to balance a reaction in the ion electron method. Okay, so now we'll do the balance in the ion electron method. Ion electron method. Ion electron method. Now now we'll take the very common example, very common reaction, that K2 Cr2O7 when it reacts with FeSO4, when it reacts with FeSO4 plus H2SO4, then what is produced? Here it is produced that K2SO4 plus Cr2SO4 whole 3 plus Fe2SO4 whole 3 plus H2O. So this is the common reaction where we will do the balance by the ion electron method. So first of all, we have to, it's as it is the ion electron method. So first of all, we have to express the reaction in the ionic form. Okay, so how is it possible to express the reaction in the ionic form? So from here we can write down the reaction in this way, that Cr2O7, it is the ionic form, Cr2O7 2 minus plus Fe2 plus 2H plus, or only H plus, because during the balance will manage this fact. So here we can write down only H plus. Then from here what we can write down, Cr3 plus Fe3 plus H2O. So this is the ionic form of the reaction. Okay, so now oxidation half reaction. What will be the oxidation half reaction? From here I think it is clear that oxidation half reaction will be, from here we can write down that Fe2 plus 2 Fe3 plus E. This is the oxidation half reaction. Now if you write down the reduction half reaction, then what will be the reaction? Then Cr2O7 it is 2 minus, then Cr3 plus. This is the reduction half reaction. Okay, so now first of all we have to balance balancing the Cr atom. So first step we will balance the Cr atom. Okay, so first step is that we will balance the Cr atom. So if we want to balance the Cr atom, then what happened? Just we can write down that from here that Cr2O7 2 minus 2 Cr3 plus. See, the first step we have to balance the Cr atom. Second step, to equalize the number of oxygen atom on both sides, 7 water molecules are to be added on the right side. That means if there is a left side there is an oxygen, but right side there is no oxygen, so how is it possible to maintain the oxygen? Just we have to add here the 2 Cr3 plus here it will be 7 H2O. So in the next step or the second step, first step, what was the first step? I again repeat, first step just we add or we check the number of chromium atom, number of chromium here. Second step, to maintain the oxygen atom, here 7 H2O we have to add here, such that the oxygen should be balanced. Now their hydrogen is extra here, isn't it? Now there is one extra atom is present, that is the hydrogen. So now what happened? To balance the hydrogen atoms in the both sides, we have to add the H plus, since it is the acidic medium. No problem, because H2SO4 already present, so we can use the H plus also. So to maintain the H2, to maintain here that the H number of H should be same. So what happened, in this side we can add 14 H plus, isn't it? If we add the 14 H plus, then 7 H2O, 7 into 2 14, so 14 14 will be balanced. Okay, so this is the third step, we have to maintain the hydrogen. Now for equalizing the charge on the both sides, 6 electrons are to be added in the left side, because charge should be same now. So if it is if we want to maintain the charge, then we have to add the 6 electrons here. Okay, so now the reaction become that Cr2O7 2 minus plus 14 H plus plus 6 electrons, because if you look the oxidation number change, you will understand clearly that why we have to add the 6 electrons. This is a very simple thing. And arrow 2 here 3 plus 7 H2O. Now for balancing the number of electrons in oxidation and reduction reaction, the balanced oxidation half reaction is multiplied by 6 and the balanced reduction reaction by 1, because the number of change of the electrons in oxidation and reduction reaction should be same, isn't it? For both sides it should be same. So to for this purpose, what happened, that we have to write down both the reactions. We have to write down both the reactions. We have to write down in this way, that oxidation reaction. What is the oxidation reaction? Oxidation reaction was the Fe, just Fe, it was the Fe 2 plus 2 Fe 3 plus E. And what is the reduction reaction now? Reduction reaction is actually Cr2O7 2 minus plus 14 H plus 6E, then 2 Cr 3 plus 7 H2O. Now look here, that to maintain the electron number of electrons should be same, so we have to multiply the first equation with the 6. Okay, it will be 6, as that 6 electron and 6 electron should be cancelled out. So for this purpose, that 6 electron and 6 electron should be cancelled out. For this purpose, what happened, we have to multiply it by oxidation. This is the oxidation reaction. This is the oxidation reaction, this is the reduction reaction. Reduction reaction is no problem, there is 6 electron by multiplying only 1, but here we have to multiply the 6. Okay, and then final equation become, what will be the final equation? The final equation become, if we write down the final equation, then it will be 6 Fe 2 plus Cr2O7 2 minus plus 14 H plus, it gives 6 Fe 3 plus 2 Cr 3 plus 7 H2O. So this is the full reaction. After adding we get. Now this balanced equation has been expressed in the ionic form, so the equation can be represented in molecular form also. Okay, so when we represent the molecular form, then the equation looks like that it is almost same with the molecular form, and the equation become here in the complete equation become that 6 FeSO4, there is an FeSO4 plus K2 Cr2O7 plus 7H2SO4. Here look 14H plus, so here that's why 7H2SO4, 7 into 2 14, okay, in this manner. Then 3 Fe2SO4 whole 3. Here look 6 Fe3 plus, so that's why 3 into 2 equal to 6 plus Cr2 SO4 whole 3. Same case, 2 here, so that's why here Cr2 SO4 whole 3 plus K2 SO4 was there plus 7H2. So in this way you have to balance the reaction, and this is called the ion electron method. This method is very important, and you know, there is a very common type of question arise here, that there may be one reaction and you have to show step-by-step process by which you can is it possible that that what will be the coefficients of the reaction or after balancing, but you have to show each and every step, otherwise you will not get the full marks. Okay, so you have to practice a lot step by step process. First of all, you have to write down the reaction in the ionic form. Second step, you have to identify the oxidation reaction and reduction reaction. Then you have to maintain the atoms. Then if there is any oxygen extra, then you have to add the water molecules. Now to maintain the hydrogen, you have to use the H plus in the left hand side if it is the acidic medium. If it is the basic medium, then you have to use the OH minus, the another case. And then you have to maintain the electrons. Then you have to write down the full reaction, and from the full reaction, full ionic reaction, there should be an information by which you can write down the full reaction. I'll give you some home task for you. That means I'll give you some reaction which you have to do in your home, that what will be the coefficients after balancing the reaction. Okay, so just note down the reactions, then it is take it as a home task for you. Okay, so like if it is the reaction is like this: KMnO4 plus H2C2O4 plus H2SO4, then K2SO4, then MnSO4, K2SO4, MnSO4, then CO2, then H2O. So you have to follow the ion electron method properly, then you have to balance the reaction. Okay, and then you have to identify the coefficients also here. Okay, then I can give you another example in basic medium, where you have to add the OH minus. By adding OH minus, you have to maintain the H and O oxygen properly, oxygen and hydrogen properly. Like Zn, very common example, Zn plus NaNO3 plus NaOH, it produces Na2 ZnO2 plus NH3 plus H2O. So this is the complete reaction, and not complete reaction without you have to do the balance by ion electron method, and you have to practice in this way. There are so many examples in any of the standard book. You can check that there are so many such kind of examples are available, which you have to practice a lot properly. You have to practice, then it is possible to balance the reaction. Okay, I'll give you another example. This is a little bit different types of example which you have to do also. Like if it is the like NaBiO3, NaBiO3, okay, NaBiO3 plus MnNO3 whole 2, NO3 whole 2 plus HNO3, then Ma, then Na, MnO4 plus BiNO3 whole 3 plus H2. This is the another example where you have to balance the reaction. Okay, so in this way you have to practice a lot, and that's all for today. Thanks for attending the class, but you have to practice a lot. Repeatedly I am telling you, otherwise it is not possible to balance the reaction in the ion electron method. Okay, so thank you. Meet with you in the next class with a different topic.